Hello. Now, we're going to look at something called relative frequency today, and relative frequency is really just experimental probability. If we run a bunch of experiments, can we figure out the probability of an outcome in the future? So let's look at the English of our word that we're dealing with today, relative frequency. So frequency just means how often we see something. If we said that we saw someone frequently, it would mean that we saw them quite often. So frequency just means how often are you seeing something. Relative frequency means how often are you seeing something compared to the total number of times that you run an experiment. So let's put this into practice. If I flip a coin 10 times, we get 8 heads. What is the relative frequency of getting a head? Well, the relative frequency, which I'm going to abbreviate to RF, of getting a head, which I'm going to put in brackets H. I can write that a little bit neater. So the relative frequency of getting a head would be equal to how many times I got a head divided by the total number of times I ran the experiment. So I got 8 heads out of 10 times I ran the experiment. So there's a few different ways I could write this. I could change this into a percentage and I would get 80%. 80% of the time I got a head. Or I could write it as 0.8. Or I could leave it as a fraction, but if I did, I was going to simplify it. And if I simplify that down, I'd get 4/5. So if I was leaving it as a fraction, I would have to simplify it down to 4/5. Now, those are the different ways of writing it. It's important we are able to deal with all of them because they're useful in different circumstances. But again, our relative frequency of getting a head was equal to the number of heads we got, how often we got a head, number of heads divided by the number of times we ran the trials or the experiment. So trial and experiment mean basically the same thing in this circumstance, and in this case the trial or the experiment is every time we flip the coin. So we got 8 heads out of 10 trials, out of 10 experiments of flipping the coin. But flipping a coin 10 times isn't really that often. We could do it an awful lot more. It doesn't take very long. So if we spent a little bit longer on it, we flipped the same coin 100 times. And this time, out of that 100 times, we get 60 heads. So what is the relative frequency of getting a head now? The relative frequency has changed because we've run more experiments. The relative frequency is now different. So the relative frequency of getting a head, this is part 1 of our question, relative frequency of getting a head now is different because we've gone and run 90 more experiments, trials, is going to be, we got 60 heads out of 100 experiments. So we could write that as 0.6, or we could write that, as 60%. Or if we wanted to write it as a fraction, we would end up writing it as 3/5. If we simplified it down, looked for our common factor of 20 top and bottom. So these are the different ways that we could write our relative frequency. And again, it's just the total number of times we see something we want divided by the total number of times we ran the experiment or ran the trial. Now, what would be the relative frequency of getting a tail? With the same experiment, I wasn't exactly told how many times I got a tail, but I can work it out. If I'm flipping a coin, I only have 2 options. I could get a head or I could get a tail. So if I got 60 heads, I must have gotten 40 tails. 40 out of 100. Which I could write as 0.4, or I could write as 40%, or I could write as 2/5. Again, if I recognize I have my common factor of 20, top and bottom. Now, something to point out about our relative frequency of getting a head or a tail is that if I add up the probability, relative frequency is just an experimental probability, the probability of getting my head plus the probability of getting a tail, if I add those together, I get 1. 3/5 plus 2/5 is equal to 5/5 is equal to 1. Now, does that make sense? Well, yes, it does, because these are the only two possibilities. So if I add up my probability of getting a head or a tail, this is the probability of getting a head or a tail, and I'm definitely going to get either a head or a tail when I flip my coin. So it makes sense that the probability of getting a head or a tail would be 1, because I'm definitely or certainly going to get either a head or a tail. It covers all of my possible outcomes. Now, part 3. So this was an aside. This wasn't part of part 2. Part 3. Which relative frequency is more accurate? Now, in this case, we're referring to the first question versus the second question. So we're back to looking at the relative frequency of heads we got in part 1 and the relative frequency of heads we got in question 1. So which one is going to be more accurate? Well, this is simply an intuition question. If we've run the experiment more times, then we are going to have a better picture of what this coin does in general. If we flipped the coin 1,000 times and we found out how many heads we got when we flipped the coin 1,000 times, that would be even more accurate. That would tell us even more about the probability of getting a head when we flipped the coin than when we flipped it 100 times. So our relative frequency from part 1 here, our relative frequency of getting a head, relative frequency of getting a head of 60% is the more accurate one, is more accurate because we've run the experiment more times. Ran the experiment more times. So, and that is the type of answer that we can give if we're asked which experiment would be, which relative frequency would be more accurate. Anytime we have run the experiment more often, that means that we are going to get a more accurate result. And that is what we need for relative frequency.